The AutoGen team keeps on moving very fast, and there are a few exciting updates that I wanted to cover today. I'm going to discuss them briefly. I'm going to share my learnings. Keep in mind that this stuff is very new, so I'm also trying to figure out the implications and the derivatives of these updates. There are two actually, major updates. Let's start by covering the first one, which is easier to comprehend. And this is a new notebook that was published by the AutoGen team, and it's called Society of Mind. Society of Mind, basically you can see it over here in the GitHub repository of AutoGen. I'll just cover this and I'll then discuss what I gather from this notebook and the implications. So basically this notebook demonstrates the Society of Mind agent, which runs a group chat as an internal monologue, but appears to the external world as a single agent. There are three advantages to this. First of all, it provides a clean way of producing a hierarchy of agents, hiding complexity as inner monologues. So imagine that you have... Never mind. We will just cover this in a moment because when you will see the example, you will get a better understanding. Let's move on. Second, it provides a consistent way of extracting an answer from a lengthy group chat. Now, this is great because normally when we have a conversation in the group chat, things get messy and we don't know what is the bottom line. And this happens very often. And in this case, as I stated, normally it is not clear which message is the final response, and the response itself might not always be formatted in a way that makes sense when extracted as a standalone message. So in this case, when you are using the Society of Mind agent, you do get a bottom line, like a final response. And it is also providing a way of recovering when agent exceeds their context window, because when agents discuss, it might be a very lengthy conversation. So in this case, the inner monologue is protected by try-catch blocks. So basically, it won't throw an error. It keeps on, at least based on my understanding, it keeps on adjusting and recovering until it spits out something that makes sense. Now, I won't cover the requirements because this isn't... I try to say that this channel isn't about installations. It's about applications and implications and implementations. And yeah, I don't want to cover the installation. It's pretty straightforward. But let me show you the examples that they are sharing. In this example, we will use an assistant agent and a user proxy agent configured for code execution to work together to solve a problem. Executing code requires at least two conversation turns, one to write the code and one to execute the code. If the code fails or needs further refinement, then additional turns may also be needed. When we will then wrap these agents in Society of Mind agent, hiding the internal discussion from other agents. Though it will appear in the console, obviously, and ensuring that the response is suitable as a standalone message. Now, this is like the inner monologue. We have the assistant, and note that they added the inner assistant for ease of understanding in this example. So we have the inner assistant and the code interpreter. Inner code interpreter, and this is the group chat, and basically the manager is assigned like the group chat, and then so basically we have these two agents, the code interpreter and the inner assistant. It's a group chat. Now we're constructing and running this in a Society of Mind agent. So we basically wrap the inner group chat, this one, in one agent. And we also create a user proxy to talk to it. So imagine, by the way, I asked DALL-E to create an image representation of this concept. So imagine we have, let's say this is you, and you want to use an agentic framework, let's say AutoGen. So in this case, you have many agents that you can discuss with, but each of these agents can also be built from other smaller teams of agents. And in this case, we have a smaller team of agents, which is like the developers, like we saw here. And once they finish let's say they discuss about a coding example, they finish the discussion, they are going to produce to this guy the bottom line of the discussion, let's say the code. And afterwards, we can have all the other agents in this level that are discussing, let's say they want to build a product, but they wanted this guy to come up with the code solution. So he is going to return to the whole conversation the final code. So it's going to be shorter and more concise. So it's not going to cover a lot of, it's not going to demand a lot of tokens. Let's just move on with the example and you'll get a better understanding. So as you can see here, again, this is like the inner monologue. Now we wrap the inner group chat with Society of Mind and create user proxy to talk to it. So the task is to figure out on which days in 2024 was Microsoft stock higher than $370. We define the Society of Mind agent, and we only define the user proxy, and the user proxy initiates the chat. And he asks on which days in 2024 was Microsoft stock higher than $370. And as you can see, they start the conversation. They are proposing a code. There was an error with the code. The error indicates that Y-Finance model is not installed on your system. To resolve this, you need to install Y-Finance library. This is like in the inner monologue. It's only we can only see it in the console, but we won't have these messages in the front-end conversation. So we have this. And then it seems like the Y-Finance library has been still the inner monologue. They are trying to solve, like to improve the code. They execute the script. This is the code block. And this is the output. The output indicates that Microsoft stock was higher than $370 on the following days in 2024. And now the Society of Mind agent, which consists of the two agents, is going to give us the bottom line. Microsoft stock was higher than $370 on the following days in 2024. And now we cover the remarks. First, the user proxy sent only one message to the Society of Mind agent and received only one message in response. So he sent the first message and he got only this message. All this conversation was in the mind of the Society of Mind, and it was, as you can see, it was the inner assistants that discussed this. So it just creates a better hierarchy, and it allows more room for specializing of each agent. And as we saw before in the advantages that they cover in the notebook, they also have the fact that they are providing like a very concise response at the end. It's also producing a hierarchy, and they also have a way of recovering because the inner monologue is protected by try-catch blocks. I think that's pretty much it with regard to the Society of Mind. I think it's just another tool that will allow us to better organize agent swarms. It allows more flexibility, and as I say here, the responses are going to be formatted better because they can stand alone, and it's just an interesting concept that will allow us to play around with different types of organizations of our agentic swarms. So this is the first concept that I wanted to cover. And the second concept is AutogenBench. before we cover AutogenBench, let's discuss about benchmarks, and I want to talk with you about HumanEval benchmark. Basically, HumanEval benchmark, I have this right here. So HumanEval benchmark is a benchmark that is designed to evaluate the capabilities of large language models like GPT. It specifically focuses on assessing how well these models can generate correct and efficient code given a programming task. HumanEval consists of a collection of programming problems, each accompanied by a description, a set of function signatures, and test cases to verify the correctness of generated code. I will show you an example in a moment because I have an example already. And it's very important to understand that anything that we do, at least anything that I do, I want it to be data-driven. And because context matters and changes all the time, we want to have abilities to isolate variables and actually understand what is performing better objectively. So there are many ways to assess different LLMs, and by the way, there are many like LM Scoreboards. You have in the Hugging Face leaderboard. So you have this OpenLLM leaderboard, for example. And this is somewhere, this is a resource that you can use in order to see what are the top performing LLMs. And this is based on different benchmarks. So we have the Hella Swag test, we have the ARC test, MMLU test. I'm not going to dive into these at the moment, but basically you can read more about this in this notebook in the Hugging Face. It's very interesting. These are benchmarks that can be used in order to assess different LLMs, and they are being used to assess different LLMs. And over here, if you're interested, let's say you want to download an LLM to LM Studio and you're not sure which you should choose, so you can filter over here based on model size, based on precision, based on model types. Then you can just sort out by the results. But this is just an example of how benchmarks can be useful for us. Now let's go back to discussing HumanEval because it's important for the rest of the video, because we are going to discuss AgentEval, which is a new framework that AutoGen team introduced, and this is the topic of the video. So each problem in HumanEval comes with a description that outlines what needs to be achieved. This description is similar to what a developer might write when specifying a task. The language models are expected to understand these descriptions and generate code that fulfills the requirement. Then we have the function signature. Basically, HumanEval provides function signature for the problems. These signatures indicate the name of the function to be implemented, the expected input parameters, and the type of output. Then we have test cases. We use them to evaluate the correctness of generated code. And then we have evaluation metrics. Now, they are saying HumanEval is significant because it provides a standardized and challenging benchmark for programming with LLMs. It goes beyond simple code generation tasks to evaluate a model's understanding of complex problem descriptions, its ability to generate syntactically and semantically correct code, and its performance across a wide range of programming problems. Now, I wanted it to elaborate with an example to make it easier to understand. So here's a problem description. Write a function that takes an array of numbers as input and returns the sum of all positive numbers in the array. If the array is empty or there are no positive numbers, the function should return 0. Now, this is the function signature, and these are the test cases. Sum of positive should return 20, sum of positives with this input should return 0, and sum of positive with this input should return 0. An LLM like GPT would then generate a code based on the problem description and the function signature. And a correct and efficient solution generated by the model might look like this. Now, the next step is HumanEval is going to test what the LLM produced, and based on this, it's going to return a score. And GPT wrote a better explanation, so let's just read this. The benchmark assesses not just the model's coding skills, but also its understanding of natural language descriptions, its ability to apply logical and mathematical concepts, and its proficiency in syntax and semantics of the programming language in question, in this case Python. The ultimate goal is to quantify how well LLMs can assist in real-world programming tasks, thereby providing insights into their practical utility and areas for improvement. So basically, HumanEval is a dataset with many programming problems and functions that are supposed to solve these problems and test cases. Now, whenever we have a new LLM, we are going to run this LLM through all these problems in the HumanEval dataset, and based on the code that the LLM produced, we are comparing the results that the LLM produced with the benchmarks of HumanEval, and based on this, we provide the score. Now, what the AutoGen, by the way, if you want to read more about this, I highly recommend that you check out this website, which is called Papers with Code. And in this website, they have many research about all the state-of-art algorithms and code. And obviously, they have also the paper for HumanEval. It's very interesting. I used to use this website a lot when I wanted to understand which GitHub repository should I use when I was trying to solve different things. So basically, you have different papers based on different problems or solutions. So you have object detection papers. So I'm assuming we will have here a YOLO. Or you have here all the libraries and the amount of stars in GitHub, etc. Anyway, check out this website, Papers with Code. Now, we covered HumanEval. Let's move on to AgentEval. And this is a blog post that was written by the AutoGen team. It was already a while ago, in November 20. Now, the TLDR is, as a developer of an LLM-powered application, how can you assess the utility it brings to end users while helping them with their tasks? To shed light on the question above, the AutoGen team built AgentEval. The first vision of the framework is to assess the utility of any LLM-powered application crafted to assist users in a specific task. AgentEval aims to simplify the evaluation process by automatically proposing a set of criteria tailored to the unique purpose of your application. This allows for a comprehensive assessment, quantifying the utility of your application against the suggested criteria. Now they elaborated a bit over here. I think I covered this in a different video, but anyway, we have different types of problems. Problem where success is not clearly defined. For example, a user might request the system to generate an email. In many cases, this generated content serves as a template that the user will later edit. However, defining success precisely for such task is complex. What is a good email? We also have different type of problem which success is clearly defined. So for example, and this can be divided into two. When the optimal solution exists, there are tasks where one solution is possible. For example, if you ask an assistant to turn on the light, the success of this task is clearly defined. It's very obvious. Did you turn on the light or didn't you? On the other hand, success can be clearly defined in problems when we have multiple solutions. We observe situations, I need to drink some water, just a sec. Okay, we observe situations where multiple trajectories of agent behavior can lead to either success or failure. In such cases, it is crucial to differentiate between the various successful and unsuccessful trajectories. For example, when you ask the agent to suggest you a food recipe or tell a joke. In the AgentEval framework, what they are doing, they are currently focused on success is clearly defined. Now, this is very cool what they did over here. So basically what they did, they built a critique agent, and the goal of the critique agent is to suggest a list of criteria that can be used to assess the utility. So for example, the critique agent, the system message of the critique agent, by the way, we are using AutoGen for building the critique agent. You are a helpful assistant. You suggest criteria for evaluating. Wait a second. Let's copy this because it will be easier to read. Okay, you are a helpful assistant. You suggest criteria for evaluating different tasks. They should be distinguishable, quantifiable, and not redundant. Convert the evaluation criteria into a dictionary where the keys are the criteria and the value of each key is the dictionary as follows: description, criteria, description, and accepted values, possible accepted input for this key. Make sure the keys or criteria for assessing the given task. Accepted values include acceptable input for each key that are fine-grained and preferably multi-graded levels. Now let's keep on reading the paper. Next, the critique is given successful and failed example of the task execution. Then it is able to return a list of criteria. And they have examples here. I think I had it open already, but never mind. I don't want to go deep into this because it's already will become a bit too tedious. Now, after the critique agent provided parameters, we have the quantifier agent. What the quantifier agent does is providing us with an idea of the utility of the system for the given task. He is defined like this. Basically, what we're telling him, you are a helpful assistant. You quantify the output of different tasks based on the given criteria. The criterion is given in a dictionary format, is the criterion given by the critique. Notice that they break it down. One guy just gives like the benchmarks and what we are aiming for and how we should score, and the other agent gives the score. You are going to quantify each of the criteria for a given task based on the task description. And okay, now let's move on. Now, as an example, after running critique agent, we obtain the following criteria to verify the results for a math problem. So let's say we have a math problem and we ask the critique agent to give us criteria to assess. So criteria, problem interpretation, the description of what does it mean to interpret the problem correctly. So ability to correctly interpret the problem, and the accepted value are completely off, slightly relevant, mostly accurate, and completely accurate. Now, mathematical methodology. This is the adequacy of chosen mathematical or algorithmic methodology for the equation. Inappropriate, completely effective. It's a scale, 1 to 5. Calculation correctness. What is the accuracy of calculations? Completely incorrect, mostly correct, completely correct. How clear is the explanation? Not clear at all, slightly clear, completely clear. What is the code efficiency? Not at all efficient, slightly efficient, extremely efficient. I'm skipping because I don't want it to take too long. It's already taking longer than I expected. Code correctness. Now, after running quantifier agent, we obtain the result presented in figure 3, where you can see different models. So basically, we have these criteria that were given by the critique, And then the quantifier agent took these criteria and quantified the output. Now, we note that while applying AgentEval to math problem, the agent was not exposed to any ground truth information about the problem. As such, this figure illustrates, never mind, I want to move forward because I remember this is not so interesting. Now, to summarize, critic and quantifier agent can be applied to the logs of any type of application, providing you with in-depth understanding of your utility of your solution. What is the utility that the solution brings to the user of any given task? Now, this is very interesting. And a few days ago, the AutoGen team introduced the AutogenBench, which is basically a tool that allows you to evaluate agents and workflows, and it leverages the AgentEval. Now, basically, AutogenBench is designed around three core design principles. Knowing these principles will help you understand the tool, its operation, and its output. First of all, repetition. So LLMs, let's say we run a Python script, it might call an external search engine, and the results may vary from run to run. This can lead to variance in agent performance. Repetition is key to measuring and understanding this variance. To this end, AutogenBench is built from ground up with an understanding that tasks may run multiple times, and the variance is a metric we often want to measure. So let's say we are running code using an agentic framework. If we only run it once, we get one response. If we run it 10 times, we will have variance because every time the LLM is going to return different responses. So we must take into account the amount of repetitions that we used, that the agentic framework used in order to get to the solution, because if there is a huge variance, if we only test it once, we might have got the good results, even though that the solution isn't correct over the long term. So we need many repetitions. We need statistical significant amount of repetitions in order to really assess how good is the solution that was provided by the LLM. So repetition is important, and this is something that is taken into account when you are using AutogenBench. Next, isolations. Agents, they basically interact with their world in both subtle and overt ways. For example, an agent may install a Python library or write a file to disk. This can lead to ordering effect that can impact future measurements. Consider, for example, comparing two agents on a common benchmark. One agent may appear more efficient than the other simply because it ran second and benefited from the hard work the first agent did in installing and debugging necessary Python libraries. To address this, AutogenBench isolates each task in its own Docker container. Basically, let's say, trying to come up with an example. Let's see if I can. Can you come up with an example to clarify this concept? Explain to 5th grade. Let's see what it spits out. Okay, nice. So imagine you and your friend are having a contest to see who can bake cookies faster, but you both have to use the same kitchen. If you go first and get all the ingredients out, measure them, and even preheat the oven, by the time your friend starts, a lot of work is already done for them. So if your friend finishes baking their cookies first, it might not be because they are quicker, it's just that they had a head start with everything you prepared. In this case, this is why the agents or the AutogenBench is placing the agents in isolation, because it understands that if it doesn't isolate the agent, the agent that is coming second is going to have an advantage. Like in this case, if you're the second agent and you come to the kitchen, everything is already well organized and the oven is preheated, so you're going to produce better results. So basically, I hope you get the idea. I think it actually was a good example. Now, instrumentation, while top-line metrics are great for comparing agents or models, we often want more information about how the agents are performing, where they are getting stuck, and how they can be improved. To this end, AutogenBench is designed to log everything and to compute metrics from those logs. This ensures that one can always go back to the logs to answer questions about what happened. Okay, now this is the installation. And this is, they're using over here HumanEval, which we covered. Now, from this output, we can see the results of 3 different repetitions of each task and the final summary statistic of each run. In this case, the results were generated via GPT. It is important to remember that AutogenBench evaluates specific end-to-end configuration of agents. Okay. And over here, they share the roadmap. The main idea that I want you to take away from this, I mean, what I'm taking away, and I'm suggesting that you can take away, is the fact that we must have benchmarks if we want to move forward and optimize. And the AutoGen team have now created this AutogenBench, which you can run, and it will basically allow you to assess how good are your agents in a specific task. I haven't tested it in a real use case yet, but I'm going to. But I really like where this is going because the AutoGen project keeps on evolving very fast. And while it is also evolving with utility, and like I showed you before, like the society of mind, which allows you like to break down different specialties and construct an agent swarm in using different hierarchy, it is also important for us not to do things without tracking, measuring, and logging. And the AutogenBench is very important because it basically is a tool that allows us to measure and evaluate how well we've built the agentic framework. Whew, that's it for today, guys. This was way longer than expected. It was also more technical than what I usually do. Let me know if you like this format. What did you take away from this video? Was it too long? Was I reading too much instead of just sharing this blog post with you? Did you want me to clarify more? Because I do like going to the AutoGen blog and just staying updated. And I think it is important. And this is why I created this video for you guys, because I'm assuming that you guys are interested in being updated as well. But yeah, I'm happy for your feedback. If you enjoyed the video, as always, please like and subscribe and comment below. And until next time, keep on automating.